Hey guys, these past couple weeks we've done a lot with polynomials. We have added and subtracted them, we've multiplied them and divided them, we've factored them, and now we're going to look at what the graphs look like. Now we're not going to get into too much detail today. Today we're just sketching these polynomials. And what I mean by sketching is we're just going to put some points on here and decide what it will kind of look like. Okay, and so that way we can interpret polynomials and what's called their end behavior. So, for instance, okay, so whenever we have a polynomial, we can do a couple things with it. So let's say we have there's a lot of different things that can happen to it. We can have, first off, positive coefficients. So that means like if I have a positive x, and if it's positive and even, it's going to be like x squared, or x to the fourth, or x to the sixth, and so on. So if it's positive and even, what we're going to do is it's going to open in the same direction. So if we have even exponents, they're going to open in the same direction. So it's going to open up like this way and up like this way. And since it's positive, it both opens up. However, if those are negative but still even degrees, like negative x squared, negative x to the fourth, or negative x to the sixth, it's going to still open in the same direction. Think like a quadratic. It's still going to open downwards. It's still going to open in the same direction, but this time it's going to open down because it's negative. Odd degrees, think about like a cubic equation or a linear equation, like this, x or x cubed or x to the fifth or so on. It's going to open up to the right and down to the left. So that's what happens when we have a positive leading coefficient and you have an odd degree. What about if we have a negative leading coefficient and an odd degree? Well, they're still going to open in opposite directions, but instead of opening like this, it's going to open like this. Okay, so instead of opening, we're going to open up this way and down this way. That's going to be whenever we have like negative x, or negative x cubed, or negative x to the fifth. Okay, that's going to be those opposite opening directions. So first step, decide how your graph is opening. Second step, find your zeros, or I might have got that wrong. First, plot the roots, then draw on your end behavior, and then just kind of connect the dots. That's really all that we're doing today. So it's just kind of interpreting, finding where it goes, but we're not getting super duper specific. All right, so let's take a look here at number one. So number one, we have to first find our roots. Now our roots are the opposites of our factors. So it kind of goes like this. Since I have an x plus 1, we're going to set each one of these equal to 0, and that's going to tell me what my roots are. Okay? So if I have x plus 1 equals 0, that means I have a root at x equals negative 1. And I have a root at x equals positive 1 and a root at x equals 3. It's the opposite. You kind of think about your answers, your solutions, your roots. They're the opposite of what your factors are. Because what we're really doing is we're finding our x-intercepts. And those are where my factors are equal to 0. So my roots are going to be x equals negative 1, 1, and 3. And we can plot those over here. We can put a point at negative 1. We can put a point at positive 1. And we can put a point at 3. Now, we need to figure out what my ends are. And to do that, we need to count the degree of my x's. In other words, we're going to count all of the x's that are being multiplied together here. So for instance, here I have an x, and an x. We have 3 x's multiplied together. So this is going to be an x cubed problem. So what that means is that first off, we can look back at our chart, and if it's an x cubed and it's positive, there's no negative here. So it's going to be opening opposite directions. Try that again. Sorry about that, guys. So it's going to be opposite directions, and it's going to be positive. So it's going to be up like this, down like this. And so we can draw these on here. We can go up like this, down like this. Now we just connect the dots. So we go through our roots, and we connect to where we're at. That's literally all there is to it. Find your roots, and then decide where your graph is going to end up. If you need help with this, remember you can use desmos.com to help you see what your graph might end up looking like. All right, let's try number 2. Okay, number 2. First off, we're going to find my roots, or your x-intercepts, or your solutions, whatever you want to call them. So we're going to set my factors equal to 0. Okay, so this is a funky thing. This x plus 3 here, we're still just going to get my root for it. We're just going to go x plus 3 equals 0, and we get a root of x equals negative 3. Well, that's my root, but we're going to say something special about this root. This root is what we call a double root. And I'm going to write something special about this over the side. I'm going to write that double roots bounce. And what I mean by that is, on our last one, you see how my graph goes through the line? If you have a double root, instead of going through the line, it's going to bounce off the line. So if you ever see something that's squared, right, when it's squared, that's what creates a double root. So since we have this whole parentheses squared, that creates my negative 3 as a double root. And so double roots bounce. All right, then this x minus 2, that's going to give me my other root. We go x minus 2 equals 0. Pretty much it's just the opposite, right? So my other root is 2. So we're going to have a root at negative 3. So negative 1, 2, 3. We're going to have a root at 2. Okay. Now remember, that is a double root, and double roots bounce. Okay, so let's figure out what our ends are. So how many x's do I have multiplied together? Well, here I have 1x, but this x is squared. So I have an x squared here. I have 1x here. X times x squared makes x cubed. So my ends are going to be just like my ends on my first problem. Okay, it's going to be opposite, and this one is positive. So it's going to go up like this and down like that, right? So we can put this on here. We can go, okay, we're going to go up this way and down this way. Now we just connect the dots. Notice here, if I went through this one and through this one, we'd be doing wrong. We have to bounce off of this. This is a double root, and a double root bounces. So we're going to bounce off here and go back through like that. Okay? So make sure that we show that double roots bounce. Okay? It's important. All right, let's try our next one. All we're doing is sketching these out. Number 3, we have negative x times x plus 4 times x minus 1. So first off, our zeros. We're going to take each one of my factors, set them equal to 0. So negative x equals 0, x plus 4 equals 0, and x minus 1 equals 0. So divide both sides by negative 1, we get our first root. X equals 0, x equals negative 4, and x equals 1. None of these are double roots, so there we go. X equals 0, negative 4, and 1. We can put those on here. 0, negative 1, 2, 3, 4, and 1. Now, find my ends. How many x do I have? Well, I have 1x, 1x, 1x. Multiply them together, we get x cubed. However, notice this negative right here in front. If your leading number is negative, that's going to be a negative x cubed, okay? So this one is still going to be opposite, but it is negative. So if you look back at that chart on your front page, it opens up to the left and down to the right. Okay, so we can draw that on here, up to the left, down to the right, no double root, so we're going to go through here, through here, through here, and connect back over here, okay? Like I said, it doesn't have to be perfect, but the thing that you need to focus on is make sure you get your end points the right way, make sure you get your roots in the right spot too. All right, let's take a look at number 4. I'm just going to list my roots for this one. We have an x by itself, so that means I have a root of 0 for that one, because x equals 0. We have negative 5, opposite of that one. We have negative 1, and I have 2. So those are my roots. Now my endpoints. We have 1x here, 1x here, 1x here, 1x here. So how many x's do I have? I have x to the 4th. So that means that we're going to open in the same direction. It's positive, and so it's going to open up like this and up like this. Okay? So put our roots on here. We're going to have a root at 0, a root at -1, a root at -2, 3, 4, 5, a root at 1, 2. All right, my endpoints, we're going to open up this way and up this way. I have no double roots, so it's going to go like this. We're going to go through here, through, and through. And we're going to end up opening up for both of these, okay? All right, let's take a look at number 5. Same thing for number 5. So number 5, we have our x-intercepts. In this case, we have x equals 0 and x plus 3 equals 0. So once again, there's one of my roots. And my other root is going to be -3, right? Okay. However, both of these are being squared, right? So both of these are double roots. Okay, so that means that they bounce, right? So we're not going to go through those points. It's going to bounce off of it. Now my endpoints. Well, this is an x squared, right? This is an x squared. So multiply those together, and my endpoints are going to be x to the 4th. And it's positive, so we're going to be positive, same direction. And so it's going to go up like this and up like this. All right, let's put my points on here. Have a point at 0, have a point at -1, 2, 3. We're going to open up this way and up this way. So we're going to go here. Bounce off because it's a double root. Bounce off because it's a double root. And go back up that way. Okay? So, it's kind of what it looks like. All right, number 6. Going to be our last one. Number 6, we have -x plus 4 cubed. Okay, this cube is different. That is a triple root. So whenever I find my zeros, well, we're still going to go x plus 4 equals 0. And we're still going to get a 0 of x equals -4. And that's what's known as a triple root. Now, triple roots don't bounce off. They still go through, but they look kind of like a cubic equation. You know how a cubic equation has that little kink in it, right, where it goes like this? This is what's going to happen to my triple root. So anyways, there's my first root. We have a first root of -4, and my second root is x equals 1. So there we go. X equals -4 and x equals 1. We can put those on here. -1, 2, 3, 4, and 1. Figure out what my ends are. Well, if I have a triple, that's going to be x cubed and 1x. Multiply those together, we get x to the 4th. However, check this out. That is a negative in front. So we're going to have a negative in front of my x to the 4th. And then we're going to write in here, okay, so we got negative x to the 4th. We're still going to go the same direction, but we're going to go down because it's negative, and so we're going to open down like this and down like this. All right, so put our ends on there, down this way, and so check this out. It's going to go up. It's going to have like this little kink in it because it's going to be a triple, and then we're going to go down that other way. All right, so the triple root looks like a cubic graph where it has that kink in it. It keeps going up, comes back down. Like I said, it doesn't have to be specific. All right, explain what is meant by the end behavior of a polynomial function. That's just where my arrows end at the end. So you're both down, both up, one up this way, or one up this way. All right? Okay, guys, have fun sketching these polynomials. Let me know if you have any questions. Thanks, guys.